Hi, so here we are with question 2c, where x, the double derivative of x is minus 4 times the first derivative of x plus 4x is equal to 0, where x, when t is equal to x, when t is equal to 1, x is equal to 0, and when t is equal to 1, the prime of x is equal to 2. So we're just going to go ahead and solve for this equation, and as always, we're going to take the x's out and put m's in. So you get m squared minus 4m plus 4 is equal to 0, and we're going to go ahead and do our b squared minus 4ac, which is basically 16 minus 4 times 1, which is 0. So now that we know that's 0, we can go ahead and make the assumption that our equation is c1 plus c2t all multiplied by e to the negative b over 2a times t. So you're just going to go ahead and solve for minus b over 2a, which is equal to minus 4 over 2 times 1, which is equal to 2. So I'm just going to get rid of this here and put a 2t here, and this is equal to your x of t. And now we're going to just go ahead and find our first derivative of x of t. So we get our first derivative would be c1 plus, well, sorry about that, it'd be 0 plus c2 times e to the t, 2 times t, plus 2 times c1 plus c2t is equal, multiplied by e to the 2t. We're just going to go ahead and get rid of the 0 here, so you only have a c2, and now start substituting our values in. So let's start with x1. So if we do that, we'll get 0 is equal to c1 plus c2 all multiplied by e to the 2, e squared basically. And this means you can divide both sides by e squared and get 0 is equal to c1 plus c2, which means c1 is equal to negative c2. And that's our relationship between c1 and c2. I'm just going to write it up here so we can erase that part off. So I'm actually going to be using c2 is equal to negative c1 for this one, which is the same thing. I'm just multiplying both sides by negative. And we'll go ahead and solve for this. So, you know, for t is equal to 1, you get x to be 2. So we're just going to put a 2 in here. And c2 e squared plus 2 times c1 plus c2 times e squared, which means 2 c2 e squared plus 2 c1 e squared plus 2 c1 c2 e squared is your equation. Now we can just go ahead and substitute for c2 in here, and we'll get a negative c1 for all of these instances. So you'll get 2 is equal to negative c1 e squared plus 2 c1 e squared minus 2 c1 e squared. So basically this is going to cancel out with this, and you're just left with negative c1 is negative c1 e squared is equal to 2, and this means your c1 is equal to negative 2 e to the power of negative 2. So that's your c1, and that means your c2 is equal to negative, well, not negative in this case, 2e to the power of negative 2. And now we're just going to go ahead and substitute that in over there, and we'll get our x of t is equal to c1, which is negative 2e to the negative 2, plus 2e to the negative 2 t, all times e to the 2t. We're just going to take 2e outside, so we can get 2e to the negative 2 outside, sorry. So we can get something like this going. And we'll have t minus 1 here, e to the 2t, which means you can combine these two e's. So you can get a 2 e to the 2t minus 2 all multiplied by t to the negative 1, and that's your basic x to the t for 2c. This could be written in different ways. I'm sure it doesn't really matter if you substitute your C1 first or C2. It shouldn't matter. You should still get this as your answer. You could leave it like this, but it's best to simplify your equations as much as possible. I might not have done that for 2a and 2b, but it's probably because it's fairly obvious how you would simplify, just taking a number out. In this case, it could be slightly more complicated since it's a combination of 2 e to the 2t minus 2. But yeah, that's your final answer.